Okay, so when it comes to polygons, there's 4 formulas that we have to memorize, and these 4 formulas have to do with the interior and exterior angles of a polygon. So just really quickly on this strange-looking hexagon, we're going to talk about the difference between the interior angles and the exterior angles. The interior angles are the ones on the inside of the polygon. Right? And so we're going to use one formula to figure out what all of the inside angles add up to, all 6 of them. Right? The exterior angles are the angles that are on the outside of the polygon. Those angles are formed by extending the edges. So this would be an exterior angle. I could extend this edge this way. This would be an exterior angle. All right, so interior angles are inside of the polygon. Exterior angles are outside of the polygon, and they're made by extending the edges. All right, I'm going to get this picture out of here. And we're going to talk about this picture now. All right, so the formulas that we need to know the sum of the interior angles. We need to know the sum of the exterior angles. And I can go ahead and tell you right now the sum of the exterior angles, no matter what shape you're talking about, is always going to be 360 degrees. So that one's actually pretty easy. It's not really a formula, it's just a number. The exterior angles of a polygon always add up to 360. All right, and then we need to know one interior angle and one exterior angle. Now, these formulas, one interior and one exterior angle, only work for regular polygons. These up here are all regular polygons. An equilateral triangle, a square is a regular quadrilateral where all 4 sides are the same. Regular pentagon means all 5 sides are the same. Regular hexagon, all 6 sides are the same. A heptagon has 7. And then you can keep going, like an octagon has 8 and a nonagon has 9. But these 2 down here, one interior and one exterior angle, only works when all of the interior angles and exterior angles are the same. All right, so if the sum of the exterior angles is 360, you can figure out what just one is by taking 360 and dividing it by the number of sides that your figure has. So for a hexagon, you'd take 360 and divide it by 6, and you'd find that one exterior angle was 60. All right, these over here are a little bit harder. And so I have all these shapes up here because I'm going to prove to you what this one is. All right, so the sum of the interior angles. We already know that the inside angles of a triangle make 180 degrees, right? So I'm going to write that, 180. All right, if we look at a square, I can actually connect 2 of the corners of a square and break a square into 2 triangles, right? And so each one of these triangles has 180 degrees. And so then you could figure out how many total degrees are in a square by adding 180 plus 180, and you get 360. You can do the same thing with a pentagon or a hexagon or a heptagon. You can break them into triangles by connecting the corners. So a pentagon gets broken into 1, 2, 3 triangles. So you would do 3 times 180. And a hexagon, you just pick a corner to start with and you connect all the other corners. Obviously, I can't draw a line here. It doesn't make a new triangle. But so this one has 1, 2, 3, 4 triangles times 180. You can do it with the heptagon too. This one has 1, 2, 3, 4, 5 triangles. So you would do 5 times 180. To make a long story short, when you're doing these, If you take the number of sides that a figure has, so a pentagon, for instance, has 5, and you take away 2, because there are 2 sides that you cannot connect to make new triangles. So you take 5 minus 2, that's where this 3 came from, and multiply by 180. Same thing here, you had 6 sides. You take 6, take away the 2, get 4, you multiply by 180. So the formula here is the number of sides minus 2 times 180. And that formula will always tell you what all of the inside angles add up to in any of these figures. Then if you wanted to know what just 1 is, you would start with the same formula, n minus 2 times 180, and then you would divide that into however many angles you have. So you divide that by the number of sides.